So let's say you want to build a universe. You've got a free afternoon, you're feeling a little ambitious. Where do you even start? What's the first ingredient you need? A bit of matter? Some kind of cosmic blueprint? A spark of energy? Nope. According to the very best science we have, the recipe is actually shockingly simple. You start with absolutely nothing. A void, a total absence of everything. I know, right? It kind of breaks your brain. How do you get all of this? The stars, the planets, the chair you're sitting on, even your own thoughts, from a starting point of pure geometric nothing? That is the ultimate cosmic riddle, and it's exactly where our story begins. To help us figure that out, we are diving into one of the most brilliant popular science books ever written, Bill Bryson's A Short History of Nearly Everything. Welcome to the Distilled Idea, where we unpack the core arguments from landmark books. Today, we're tackling the very first part of Bryson's book, Lost in the Cosmos, to get to the bottom of the mind-bending story of our own creation. You know, the funny thing is, Bryson isn't a scientist. He's just a famously curious writer who one day realized something startling. He didn't understand the first thing about the only planet he was ever going to live on. Sure, he'd seen all the diagrams in textbooks, the neat layers of the Earth, the orderly planets, but they never answered his most basic questions. Like, how does anyone actually know how much the Earth weighs, or how old it is, or how the universe even got here? His goal wasn't just to explain the what, but the how, the messy, brilliant human story of how scientists figured all this stuff out. And if you distill his entire journey down to one core idea, it's this. Our existence, your existence, is a profoundly improbable miracle. It's a story of wildly unlikely events built from unimaginable cosmic chaos, all of it balanced on a razor's edge of conditions so perfectly just right that it just boggles the mind. It's a story of chance, physics, and almost impossible luck. Okay, so let's get into that recipe for existence. We're going right back to the beginning. From a single, dimensionless point to, well, everything. So that starting point of nothing is a concept called the singularity. Now, to get your head around this, try to imagine gathering up every single thing in the universe, every sun, every planet, every black hole, every last speck of dust, and squeezing it all into a spot. A spot so tiny, so compact that it literally has no dimensions. It's not just very small, it's a point so dense that, geometrically, it doesn't even exist. It's a place where all our known laws of physics just completely break down. And yet, from that impossible, non-existent point, everything we see erupted into being. And from that point, things happened fast. In a single, silent pulse, that singularity just inflates to heavenly dimensions. In the very first second, gravity and all the other laws that govern our universe just pop into existence. The entire instruction manual for reality gets written in an instant. Less than a minute later, the universe is already a sprawling chaos, 1,000,000,000,000 miles across, and searingly hot. We're talking 10 billion degrees. And that heat kicks off nuclear reactions, forging the lightest elements. And here's the kicker. In just 3 minutes, about the time it takes to make a cup of coffee, 98% of all the matter that will ever exist in our universe has been produced. Just like that, we have a cosmos. But even inside that for a second, something truly wild is thought to have happened. See, back in the 1980s, a young physicist named Alan Guth was wrestling with a problem. The universe is surprisingly uniform. It shouldn't be. So he came up with a theory called inflation. He figured that for just a fraction of a moment, we're talking 10 to the minus 30 seconds, that's a decimal point followed by 29 zeros and a 1, the universe went through this sudden, dramatic, exponential expansion. It doubled in size and then doubled again and again, over and over, way faster than the speed of light. And that single event is what smoothed out all the wrinkles in space-time and gave us the vast, smooth canvas that stars and galaxies could later form on. And believe it or not, we're still living with the echo of that moment. In fact, you can actually see it. It was discovered almost by accident in the 1960s. Two astronomers were trying to use a big radio antenna, but were being driven crazy by this faint, persistent hiss they just couldn't get rid of. It was coming from everywhere. Well, what they'd stumbled on was the cosmic microwave background, the ancient afterglow of creation. If you have an old TV and tune it to a dead channel, about 1% of that fuzzy static is that very same radiation. It's the oldest light in the universe, still washing over us. So next time you're complaining there's nothing on, just remember, you can always watch the birth of the cosmos. Okay, so the fact that the universe exists at all is a miracle, but the fact that it exists in a way that allows us to be here to notice it, well, that's an even deeper mystery. It's what scientists sometimes call the Goldilocks riddle. How did we end up in a universe that is so exquisitely, so perfectly just right for us? I mean, the fact that our universe seems perfectly tailored for life is one of its greatest puzzles. Britain's astronomer royal, Martin Rees, has this fantastic analogy to explain one possible answer. He says, if there is a large stock of clothing, you're not surprised to find a suit that fits. His idea suggests there might be many, maybe even infinite universes, a multiverse, and each one has a totally different set of physical laws. Most would be sterile, dead, but if you have enough of them, it's not surprising that at least one, just by sheer chance, would have the right conditions for life to show up. And of course, that's the one we'd find ourselves in, because we couldn't exist anywhere else to even ask the question. And the tuning required is unbelievably precise. Let's just take one example: how efficiently stars fuse hydrogen. The value for this process is exactly 7/1000ths, or 0.007. Now, if that number were just a tiny bit lower, say 0.006, fusion would be too weak. The universe would be nothing but hydrogen forever. But if it were a little higher, 0.008, the process would be so frantic that all the hydrogen in the cosmos would have burned up billions of years ago. The value is exactly perfectly right to allow stars to burn steadily for eons, creating the conditions for life. Change it by a fraction of a percent, and we're just not here. So we've got a finely tuned universe. But what about our own cosmic backyard? Well, this brings us to a hard truth. We're going to have to dismantle that convenient picture you have in your head from all those solar system maps. Yeah, those maps you see in school, with all the planets lined up in a neat little row, they're a necessary lie just to fit it all on one page. To get the real scale, let's shrink things down. Imagine the Earth as the size of a single pea in your hand. On that scale, Jupiter would be over 300 meters away. That's 3 football fields. Pluto? It'd be 2.5 kilometers away. And at that distance, Pluto itself would be the size of a bacterium. You literally couldn't see it. Space isn't just big, it's mostly empty. Oh, and the nearest star to us, Proxima Centauri, on our pea-sized Earth scale, it would be 16,000 kilometers away. To put a number on it, more than 99.999% of our solar system is just empty vacuum. All the planets, the sun, all the moons, all the stuff. It feels less than a trillionth of the actual available space. It is a near-perfect void with a few lonely, microscopic specks of matter floating in an ocean of nothing. That's the reality of our neighborhood. But hang on. This story of our origins, it has a huge hole in it. We've said that the Big Bang only cooked up the lightest, simplest gases, hydrogen and helium. But look at your hand. You are made of heavy, complex stuff: carbon, nitrogen, oxygen. So if the Big Bang didn't make the ingredients for life, where in the universe did you come from? The answer is one of the most poetic and profound truths in all of science. This is the story of where you really, truly came from. The atoms that make up your body, they were forged in the heart of a dying star. See, inside massive stars, intense pressure fuses light elements into heavier ones. But that process stops at iron. To create the rest of the elements, the gold, the oxygen, the carbon that you're made of, you need something way more violent. You need a supernova. That's what happens when a giant star runs out of fuel and collapses in an explosion of unimaginable violence. For just a little while, a single dying star can release the energy of 100 billion suns, burning brighter than all the other stars in its galaxy combined. And for a long time, the world's greatest hunter of these cosmic fireworks wasn't some high-tech observatory. It was one man, the Reverend Robert Evans, from a small town in Australia. From his back deck, with a simple telescope, he had this unbelievable, almost savant-like ability to memorize the star fields of hundreds of galaxies and then spot the one new, faint little pinprick of light that wasn't there the night before. His talent was like spotting a single new grain of salt on a line of tables stretching for 2 miles. In his lifetime, he visually discovered 47 supernovae. That's a record for one person that will probably never be broken. When somebody asked him why he spent thousands of hours in the dark, just patiently scanning the heavens, Evans gave this simple, profound answer. It just seems right that an event of that magnitude should be witnessed. It's just this beautiful expression of that human drive to observe, to be present for the universe's grandest moments. And it was the work of the brilliant and famously cranky astronomer Fred Hoyle that finally answered our question.
Now, ironically, Hoyle hated the Big Bang Theory. In fact, he's the one who coined the name Big Bang on the radio, just to make fun of it. But it was Hoyle who figured out that these stellar explosions, the ones Evans was watching, are the only places in the universe hot enough to forge heavy elements. They are the cosmic furnaces that create carbon and nitrogen and oxygen. And then, in their final violent act, they spray those new life-giving elements out into the cosmos. And that stardust, it eventually clumps together to form new stars, new planets, and ultimately, us.
So let's pull all of this together. We've gone from a dimensionless point to the furnace of the stars. Why does any of this matter? What's the real takeaway from this journey from cosmic dust to conscious beings? What Bill Bryson shows us, I think, is that we are the product of a staggeringly long and improbable chain of events. From the precise, inexplicable tuning of physics in the first second of creation, to the vast emptiness that made a stable solar system even possible, to the explosive death of some ancient nameless star that forged the very atoms now circulating in your blood. It means you are simultaneously insignificant on a cosmic scale and profoundly, improbably special, a momentary lucky arrangement of stardust that has somehow achieved the remarkable ability to wonder where it came from. This has been our distillation of the first part of a short history of nearly everything. If you found this fascinating, I really can't recommend reading the full book enough. Subscribe to The Distilled Idea for more deep dives into big ideas.